Okay, so I have to make a confession.
Oh.
For the last year, maybe more, I've been walking around with this mental model of how AI agents talk to databases. And I was pretty sure I had it all figured out.
Right, the standard playbook.
Exactly.
Yeah.
You know the drill. You take your LLM, you give it a connection string, you paste your entire schema into the prompt.
Pages and pages of create table statements.
Right. And you just tell it, go write some SQL, text to SQL. Done. I thought, that was the cutting edge.
And look, if you go on YouTube right now or any tutorial, that is exactly what they're teaching. It's the brute force method.
Right. But then I spent the weekend really digging into the docs for this new project, the Inventory Watchdog.
Yeah.
And specifically the protocol it uses.
Okay.
And I realized I've been doing it a hard way. Actually, scratch that. Maybe the dangerous way.
Dangerous is probably the right word for it, yeah.
We are looking at a stack today that basically claims to end the era of AI manually writing raw SQL. We're talking about a protocol called ORMCP, and an agent that doesn't just chat it, reverse engineers your database on the fly.
Yeah.
And honestly, it felt a bit like watching someone invent the wheel while I've been over here dragging rocks.
It is a total paradigm shift. I mean, we're moving from a chatbot that essentially guesses your data structure to an autonomous agent that fundamentally understands the business logic.
So let's set the stage for everyone listening. The core conflict here is the bridge. You've got your shiny new AI GPT-4, Claude, whatever, and on the other side, your reliable relational database. Postgres, Oracle.
And connecting them is usually a nightmare. It's what I call the hallucination trap.
The hallucination trap. I like that.
Because to get the AI to query the database, you usually have to teach it SQL. But LLMs are creative engines. They're not logic engines. They just make stuff up.
They hallucinate table names. They try to join things that have no relationship.
For worst case scenario, they write valid SQL that exposes data it absolutely should not.
The dreaded select star from users?
Precisely. You are asking a creative writer to do the job of a database administrator. It's a recipe for disaster.
Okay, and that brings us to the solution we're breaking down today. ORMCP. Object Relational Model Context Protocol. So before we even get into the watchdog agent, we have to understand the plumbing. What is ORMCP?
So to understand ORMCP, you have to see the gap it's filling. Usually, developers try to force the AI to speak the database's language. SQL. Right. ORMCP flips that. It makes the database speak the AI's language.
Which is objects.
Semantic objects. Think about it. LLMs understand concepts. They get product, supplier, order. They don't naturally get inner joins or foreign key constraints.
No.
So ORMCP creates this layer where the AI can just say, give me the product object where the stock is low, and the protocol handles all the translation.
Okay, but playing devil's advocate here, translation layer is a term that usually makes engineers nervous. It sounds like latency. It sounds like complexity. So how does this actually work?
It's what we call a brain surgeon approach.
A brain surgeon?
Picture the architecture like an operating room. On one side, you have the brain. That's your AI agent built with LangChain. On the other side, you have the patient, your raw database.
And you definitely don't want the brain just poking around inside the patient with dirty hands.
You certainly don't. So ORMCP sits in the middle. It's the sterile instrument. The AI speaks MCP model context protocol to the server.
And MCP, just to pause you, that's that standard from Anthropic, right? For connecting models to data.
Yes, it's becoming the standard for how models talk to external tools. So the AI sends this MCP request. But here's the secret sauce. The ORMCP server translates that into a REST API call.
Ah, okay.
And that call goes to a microservice called Gilari.
Gilari. I saw that name all over the source code. It seems like it's doing all the heavy lifting.
It is the workhorse. Gilari is a microservice framework, and it's powered by something called JDX Java Data Exchange. This is where the rubber meets the road.
Okay.
Gilari takes that clean REST request like get product ID 5 and uses JDX to convert it into highly optimized dialect-specific SQL.
So the AI never writes a single...
Not one line. Not one character of SQL.
A single line of SQL.
Ever.
Never. The AI asked for a product. Gilari figures out the table structure, the columns, the query syntax or Oracle versus Postgres, runs it, and just hands back a clean JSON object.
Okay, so we have a secure bridge. But here's where I got skeptical. When I read the docs, usually object relational mapping or ORM just means configuration hell.
Right.
I thought, great, now I have to manually map every single table in my database to some JSON object. If I have 500 tables, I'm writing XML files for a month.
That is the traditional bottleneck, the mapping tax, we call it.
But then I found this script in the repo, smartreverseengineer.dash, and I realized, wait, is this doing what I think it's doing? This is the magic feature. This is what separates this stack from just, old school ORM. It's the smart reverse engineering.
Walk me through this. So let's say I have a legacy Oracle 19C database. It's 10 years old, it's messy. I point this tool at it. What happens?
Okay, so it scans the schema. It pulls all the tables, the columns, data types. That's the easy part. But then it does something really clever. It analyzes the foreign key relationships.
So it sees that the supplier table has a primary key that also shows up in the product table.
Exactly. And it infers, aha, this is a one-to-many relationship. A supplier has many products, and it automatically generates a Java object model and the mapping files, those RebJDX files, instantly.
Without me typing anything.
Completely automated. It's essentially building a cognitive map of your data structure for the AI.
That is wild. So in the context of this inventory watchdog project, that means the system didn't just find a flat list of tables.
No.
It understood the web of data. It knew custom order links to order item.
Think of it like this. You drop a taxi driver into a new city. If you don't give them a map, they have to drive down every single street reading signs to figure out where they are.
Right.
That's what happens when you dump a schema into an LLM's context window. It has to figure it out every time.
Which costs money.
Huge amounts of tokens. But with smart reverse engineering, you're handing the AI a preloaded GPS of the entire city. It knows exactly how to get from customer to order because the map was generated before the car even started.
And that completely eliminates schema introspection, right? The AI doesn't have to waste time querying the database to ask, hey, what columns do you have?
It removes that whole step. You point the watchdog at an existing database, run the script, and it's just ready to work.
Okay, so let's talk about the watchdog itself, because this isn't just some theoretical tool. The source material outlines a specific agent designed to save e-commerce businesses from stockouts. What's the mission?
The mission is 24/7 vigilance. The inventory watchdog monitors an e-commerce store, focuses on the stock quantity field, but the implementation is what's so fascinating. They used a smart hybrid approach.
I highlighted that in my notes. Smart hybrid. Usually people just throw everything at GPT-4 in a loop and hope for the best.
Which is slow and incredibly expensive. You don't want a brain as powerful as GPT-4 just checking if a number is less than 10. It's a waste of intelligence.
So how do they split the logic?
They separated the monitoring from the reasoning. So for the hourly checks, the system bypasses the heavy AI engine completely.
Okay.
It uses direct ORMCP tool calls. It just asks Galari, query products where stock quantity is less than the threshold.
So that's just a fast, cheap, almost mechanical query. Give me the low stock items.
Right. But, and here is the shift, once it finds a low stock item, let's say a wireless mouse with only 8 units left, it switches gears. It wakes up the React agent.
React reasoning and acting. So this is where the LM comes in.
Yes. Now the AI takes that data, wireless mouse, 8 units, and it starts to think. It uses tools like getAggregate to check the order item table. It starts calculating sales velocity.
So it realizes, hey, we have 8 units, but we're selling 10 a day. We're going to be empty by tomorrow.
That is the difference between a simple database trigger and a real AI agent. A trigger just says, stock is low. The agent says, you are in trouble by tomorrow morning because of your sales velocity.
And then it acts. It doesn't just log an error.
No, it uses the send mail notification tool. It drafts an HTML formatted email. It suggests a reorder quantity based on that math, and then it sends it via Gmail SMTP right to the admin.
I love that workflow. It's economically rational. Use the cheap deterministic tech for the boring checks, and only use the expensive probabilistic tech for the actual analysis.
It's efficiency by design. And if you look at the toolset it has, it's query products, getAggregate, has a full toolkit to manage the business without ever seeing a line of SQL.
Speaking of economically rational, let's get into the numbers. The source material had this section on token economics that was pretty startling. We hinted at this, but let's break it down. Why is the ORMCP approach so much cheaper?
This is the geek out moment for the CFOs listening. When you build an AI app the traditional way, the text-to-SQL way, you have to dump that entire database schema into the prompt.
Every single time. Just here are my 50 tables, here are all the columns.
For every single query. The analysis in the source estimates that this approach burns about 80 tokens per query just on schema reasoning and, correction loops.
Okay, 80 tokens.
If you're running a high-volume app, that adds up fast. The estimate was around $2,400 a month for a busy system.
Wow. Okay. And the ORMCP way.
Because the AI is working with those pre-mapped semantic objects, it doesn't need the schema dump. It just needs the tool definitions. The estimate drops to about 25 tokens per query.
From 80 down to 25.
Which brings the monthly cost down to roughly $750. That's a 68% reduction in token overhead. 68%.
That's the difference between a profitable SaaS product
Right.
and one that burns all its margin on API fees. But honestly, the cost is great, but the security implications seem even bigger to me. We talked about select star, but how does this architecture actually stop data leakage?
It creates a wall. Gilari and JDX, they act as a firewall. When the AI requests a user object through ORMCP, Gilari looks at that .jdx mapping file.
Right.
And it only fetches the columns that are explicitly mapped in that file.
So if I have a social security number column in my database, but I didn't map it in the .jdx file.
The AI literally cannot see it. It effectively doesn't exist to the agent.
That is huge, because usually we rely on prompt engineering for security. We tell the AI, please don't look at the password column.
Which is what I call hope-based security.
Hope-based security, I love that. And this replaces it with architecture-based security.
Exactly. You define the boundary at the code level, not the prompt level.
So, okay, we've got the brain surgeon architecture, the magic reverse engineering, the hybrid workflow, the cost savings. But I have to ask about deployment. Usually when I hear microservices and Java and AI, I just hear 3 weeks of DevOps pain.
That's the final surprise. The deployment story here relies on Docker and some really smart scripting. There's a script called buildall.esh.
I saw that. Does it actually work like it says on the tin?
It's a bit of a revolution for developer experience. You run this one command, and it just handles the entire pipeline. It triggers the reverse engineering, it compiles the Java code for Gilari, builds the Docker image, and deploys the container.
One command.
One command. And it even handles the networking automatically. You know the pain of getting a Docker container to talk to a database running on your local host.
Oh, don't get me started. Localhost inside the container is not localhost on my laptop. I have lost days to that problem.
This setup detects the environment. If it sees it's in Docker, it automatically swaps the configuration to use host.docker.internal. If it's running locally, it uses the standard IP. It creates a zero manual configuration environment.
That is a quality of life feature that tells me this was built by developers who have actually suffered through Docker networking.
It shows a lot of empathy for the user. And once it's up and running, there's a web interface, a Flask app, where you can actually chat with your inventory.
Chat with it.
Literally.
Yeah.
You can type in, show me products from Tech Supply, Inc., and the agent translates that to ORMCP, hits the Gilari service, and shows you the results. It turns your database into a conversation partner.
It really feels like we're at an inflection point. I mean, if you're a developer still manually writing JSON to SQL mapping layers or pasting create table statements into your prompts,
you're living in the past. You are doing manual labor that has now been completely solved by this architecture.
It's cleaner, it's safer, and it's cheaper. I am definitely going to stop writing raw SQL queries for my chatbots. For everyone listening, you have to see this to believe it. Go check out the Inventory Watchdog project. The link is in the show notes.
And definitely look at the smart reverse engineering scripts. That is where the real magic happens.
So before we go, I want to leave you with one final thought. We've spent this whole deep dive talking about how this technology automates the database interaction. It reverses the schema, it writes the queries, it secures the data.
It removes the human bottleneck.
So, if the AI can now understand your database schema instantly, secure it automatically, and query it efficiently without a human writing a single line of SQL, what happens to the traditional database administrator?
That is the big question, isn't it?
Are we moving towards self-managing data architectures? I mean, are DBAs about to become AI data architects, or are they going the way of the switchboard operator?
I think the role shifts. It shifts from being the gatekeeper of the query to being the architect of the logic, but the job description is definitely getting a rewrite.
Something to mull over while you're optimizing your next prompt. Thanks for diving deep with us today.
Always a pleasure.
We'll see you on the next one.